Guys, welcome back to another math lesson with HKM Math and Science. This video is about gradient and direct portion and to use and understand gradient and direct portions. So by the end of this video, we should all understand what it means for two variables to be directly proportional. Also know that the gradient equals the rate of change, and also be able to use a worded problem to sketch your graph and form a linear rule. So let's just pause the video here and take a couple of minutes to write these down. Alright, so before we get on to some questions, we need to go through a couple of key ideas. And the first of these is that if two variables are directly proportional, it means that the rate of change of one variable with respect to the other is constant. It also means that the graph is a straight line passing through the origin. The rule is of the form y equals mx, and that the gradient m of the graph equals the rate of change of y with respect to x. So in this equation here, y equals mx, m is the gradient or the rate of change. Alright, so that might look like a lot of information and it might not make sense just yet, but it will make a bit more sense when we go through a couple of example questions on the next couple of slides. Alright, so let's start off by reading this question. It says water is poured into an empty tank at a constant rate. It takes 3 hours to fill the tank with 6,000 liters. What is the rate at which the water is poured into the tank? So to find the rate, it's always how much divided by the time. So if you're looking at speed, it's always distance, so how much we traveled over the time. In this case, it's how many liters was poured, which is 6,000 liters. So the rate equals 6,000 over the time taken, which was 3 hours, and that will give you the rate is 2,000 liters per hour. So that's the answer for question A there. I'll just label that A. Alright, so now let's have a go at question B here. It says draw a graph of volume V liters versus time 2 hours using this rule here. So that just means the starting time is 0 hours and the ending time is 3 hours. So let's draw the axis for the graph here. I have the x-axis down here and the y-axis here. We don't need to include that. I'll just get rid of that. We just need to label which one of these is at the x and which one is at the y. So I'll put time at the bottom. So I have time here in t hours. And going vertically, we have volume in V liters. So I just need liters there. Alright, so that's 2,000 here. That's 4,000 here. I'll do increments of 2,000 and 6,000, and hours I'll do increments of 1. So we know that the ending point is 3 hours and 6,000 liters. We only need the starting and ending point to draw a graph. And the starting point is 0 hours, so at the start of this time, and 0 liters because we had no water at the start. So starting point will be at the origin here. That's labeled 0, 0, and our ending point will be up here. Remember, always label the x-axis first. So we have 3 as the x-axis and 6,000 as the y-axis. So this is what our graph should look like here. Alright, so now let's move on to question C, part 1. It says find the gradient of your graph. The gradient is simply the same as the rate, so our gradient will just be 2,000 in this case. And now let's move on to part 2. Part 2 says find the rule for V. So in linear graphs, they always take the form of y equals mx plus c. But we've just got different letters in this case. And if you look at our graph, we used volume as the y-axis, so the vertical one. So we'll replace y with V here, volume. And m is still the gradient. We can replace it with 2,000 later. X we use, so horizontal axis, we use time. So I'll replace that with t plus c. So V equals, we know that the gradient here is 2,000. So we replace m with 2,000, so 2,000 t. And we need plus c. C is just the y-intercept. And we know that the y-intercept here is 0. So it will be plus 0, but that will make no difference. So our final answer for that will be V equals 2,000 t. Alright, so now that we've got an equation, we can do question D here. It says use your rule, so the rule over here, to find the volume after 1.5 hours. So we'll replace t with 1.5. So V would equal 2,000 times 1.5. And if you remember how to multiply decimals, this should be a breeze for you. 5 times 0 is 0. 5 times 0 is 0 again. 0 again. 2 times 5 is 10. Cross that out. Put another 0. 1 times 0 is 0. 0 again. 0 again. And 2. That gives you 0, 0, 0, 0, 3. and there's only one decimal point behind the decimal, so our final answer will be 3,000 liters after 1.5 hours. Alright, so let's move on to question D, part 2 now. It asks you to find the time to fill 5,000 liters. So we'll replace V here with 5,000 with our rule just over here again. 5,000 equals 2,000 T. So T equals 5,000 divided by 2,000. And if you work that out, that will give you 2.5 hours. Alright, so now that we've gone through one question, just pause the video here and have a go at this one by yourself. So let's start off by reading this question here. It says, on a long distance journey, a car travels 450 kilometers in 5 hours. What is the rate of change of distance over time? In other words, speed. So A here, rate of change of distance. So speed equals, we know from the slide before, it says speed equals distance over time. So we have speed equals distance is 450 kilometers over time, which is 5, and that gives you 90 kilometers per hour. Give yourself a tick if you got that correct. Alright, so now let's move on to question B. It says, draw a graph of distance d kilometers versus time t hours using that rule here. So the starting point is 0 hours, ending point is 5 hours. So you can remember, you can draw a graph with the ending point 450 kilometers in 5 hours and the starting point 0 kilometers in 0 hours. Let's start by drawing the axes here like we normally do and label the axes. So at the bottom I'll put time in hours, and vertically I'll put distance in kilometers. So kilometers, I'll do increments of 150 kilometers, and time I'll do increments of 1 hour. So that's 1, 2, 3, 4, 5. Remember, the starting point was 0, ending point was 450, 5 there. So let's connect the dots there, and that is what your graph should look like. And give yourself a tick if you got that one correct. Now next part, question C, part 1, find the gradient of your graph. Remember, gradient is just the rate, so the gradient would just be 90. Alright, now question C, part 2, the rule for D. So remember, it always uses y equals mx plus c, and we use distance, kilometers, as the y, and it asks you to use D for that. So we have D equals mx, we use time in hours, and they use t, so we'll continue using t. So it will now take the form of this equation here. So D equals, we know the gradient was 90, we don't know time, and the y-intercept, the c part, was 0, so we're just going to keep it as D equals 90t. Give yourself a tick if you got these two correct as well. Now last part, question D, this is just substituting into the equation we made just over here. So the distance after 3.5 hours, so we'll replace t with 3.5. So D equals 90 times 3.5, and that gives you, if you work that out, 90 times 3.5, that gives you 315 kilometers. And let's go to part 2, the time to travel 135 kilometers. So we're going to replace D with 135 equals 90t. T equals 135 divided by 90, and that gives you 1.5 hours. Make sure you're including your units in your answers here as well. Alright, so that brings us to the end of this video. Hopefully you guys learned something from this, and that you guys can also understand what it means for two variables to be directly proportional. Know that the gradient equals the rate of change, and also can use a worded problem to sketch a graph and form a linear rule. Thank you guys for watching. I'll see you guys all back online.